Hello, everyone. It's wonderful to see so many of you joining us live today. Thank you for taking the time to be here. You've made a great choice because today's masterclass explores something incredibly powerful, how AI and technology can create real world social impact, not just innovation for business, but innovation that can actually save lives. I'm Chetna Kapoor from Seed Global Education. We are a UK headquartered company that facilitates connections between leading global universities and students like yourselves. Our mission is to help aspiring students explore programs, connect with faculty and admissions teams, and make informed decisions about their higher education and career goals. Before we begin, let's make this interactive. Could everyone quickly drop in the chat where you're joining us from today, city or country? I mean, it's always amazing to see how global this community is. So, in the chat section, if you can drop where are you currently joining us from? Okay, we have people from Uttar Pradesh in India, which is up north, Assam, which is in the east. Dr. Pless is here joining us from Washington, D.C. All right. I would encourage people to please, we have over 100 participants in this session. Please drop in the chat section where you're from. We have Parth from Chennai. We have Aditya from Mumbai. Okay, so we have people from every corner of this country. Today's session is hosted by the George Washington University School of Engineering and Applied Science located in the heart of Washington, D.C. GW Engineering is known for cutting edge technology with real world problem solving, whether that's AI, robotics, data science, or systems engineering, and for preparing students to build solutions that truly impact the society. And today's topic is a perfect example of that. Our masterclass today will explore how computer vision and AI can help investigators identify hotel rooms from images, enabling faster and more effective rescue efforts in trafficking cases. It's a powerful look at how ethical AI can be applied responsibly, data can accelerate victim rescue, and image recognition can support real investigations on ground. So, if you're interested in AI, today's AI social impact or technology for good, you are going to find today's session incredibly eye opening. So, we are truly honored to have two distinguished guests joining us today. First, please join me in welcoming Dr. Pless. He's the Arnold C. Melzer Endowed Professor of Computer Science at GW Engineering. His research focuses on computer vision, AI, and data driven systems with applications that range from robotics to environmental and social justice challenges. His work on Traffickcam is a remarkable example of how advanced AI research can directly support humanitarian and law enforcement efforts. Welcome, Dr. Pless. We are so glad to have you with us today. We are
Thank you
also
very much.
we are also joined by Catherine Huggins, Associate Director of Admissions and International Partnerships at GW Engineering. Catherine works closely with students from around the world, helping them navigate programs, applications, and technology fields. Welcome, Catherine. Great to have you with us today. Before we
Thank you.
dive in, let's start with a quick poll to get everyone thinking. You will see the question on your screen now. Just give me a second. Yes, the question is, in your view, what is the biggest challenge in using AI for sensitive investigations? Please take a few seconds. Is it accuracy and false matches, explainability and trust in model decisions, ethical use and privacy concerns, or integration with human judgment and workflows? Just take a few seconds to answer. I see yeah, there are almost 200 participants here. All right, I'm going to end the poll now and share the results. All right, the maximum maximum people feel that it is ethical use and privacy concerns. Thank you. It's interesting to see how varied perspectives are. These exact challenges are what make responsible AI design so important. And today's session will touch on many of them. And with that, I'd love to hand it over to Dr. Pless. All right.
Thank you very much.
Thank
I
you.
appreciate the introduction. I think I am sharing the wrong thing. Um, doo-doo-doo. There we go. So thank you very much. It's an honor to be able to share some of the work that I've been doing here at George Washington University. And I'm showing a picture of the building where we work. This is an amazing facility right in the heart of downtown Washington, D.C. I arrived here about 9 years ago. This building and the fact that it collects people from computer science and electrical engineering and biomedical engineering and the Cancer Institute all in one amazing facility is part of what made me so excited to come. And the kinds of interactions and projects we build here, like this one I'm going to talk about, come from the fact that we have so many different people and perspectives all in one building. Um, so I am going to talk about a project I've been working on for about 10 years. It's called Trafficking. It's a tool that tries to support a very specific investigative use case. And there are no questionable images in this presentation, but the topic we're talking about relates to finding where people are when there are images of them, usually trying to advertise for sex services. And our collaborator in this is the National Center for Missing and Exploiting Children, Missing and Exploited Children, which is an official U.S. entity that tries to coordinate efforts to rescue children that are being trafficked. And so we have been working with them, and I'm going to share with you some of the technology behind this search interface that they've been using for the last 10 years. Um, so here is, in a nutshell, the very specific problem that we are trying to solve. So sometimes investigators come across a picture that is important to them for a case, and in some cases they don't know where in the world that picture is. Sometimes they know part of the answer, like they know it's in New York City, but they don't know which hotel it is. So we are trying to answer the broadest version of that question that says, here's a picture, where in the world was this picture taken from? This particular picture was shared by Europol. This URL is actually a really fascinating URL where they do a number of crowdsourcing questions like, do you recognize this hotel room? But also sometimes like they have an artifact like a backpack or a t-shirt or something, and they are just putting it online in hopes that somebody recognizes something and can give them a hint. So at the end of this talk, I will tell you where this picture came from, but it's an interesting exercise just for yourself to say, where do you think in the world this picture comes from? And hotels around the world all in some ways look the same. They all have beds and some kind of a bathroom and a door and a light and a nightstand, but they also look different in different places. And so that is the cue that we are trying to use. And the reason this is so important in the sex trafficking space is that not always, but often human traffickers operate out of hotels, and they often advertise with images taken inside hotel rooms. And if you can find the hotel room where a particular image was taken, you can do many things. In real time, you might be able to find victims, and our system has occasionally been used to actually implement a rescue like that. But also in the investigative case, maybe after somebody is arrested and they have pictures on their laptop or something, you can document where crimes were taken, where crimes occurred, and understand connections between people and places and so on. Uh, One of the important parts about that is for example, in the United States, if there is the same person that is being advertised in multiple different states, it becomes a federal crime instead of just a local crime, and that means there's more resources available to investigate this. And internationally, it's also super interesting from an investigative standpoint to understand if something is happening across national boundaries. Um, so I'm going to tell a story in two parts. The first I'm going to go through crazily quickly, but serendipity and how I ended up working on this project, because I think it's a good story about how important it is for students, especially young students, to grab a problem and hold on to it really tightly. And then we're going to illustrate some of the challenges that you have in biased data sets. Um, and I do hope somebody gives me a 5 minute warning before my time is up because sometimes I get overly excited about teaching in this domain. So this is a crazy project that started when I hired Abby to work on a different project in my lab, and she saw a newspaper article in St. Louis. This is now 10 years ago, but that newspaper article was about somebody who had been buried 30 years before, a crime victim, and they tried to dig up the body and they could not find the body. They dug several different places and couldn't find it, but there was a picture of the day of the burial. And so Abby's first project with me was making a map to try to use basic geometry of like where could a camera be and see this tree here and this tree here and there's a tiny billboard in the background, and we made a map and suggested where people should dig, and they dug there, and at first they found the wrong body. The crime victim was a child. The first body they found was an adult, and if I had been there the day they were digging this up, I would have, because I'm a professor and have a lot of knowledge, I would have had 100% valid reasons why we had done something wrong. But Abby was the only one that was there, and she was 22 and she had that confidence of youth. And she said, "We're really sure we're right. You should keep digging." And so they kept digging and then found the body right where we said it would be. And part of the reason she had the confidence to do that was she had read every written word about this case and knew that part of the reason it had been hard to dig up the gravesite was that the cemetery had gone bankrupt. It had become completely overgrown, and the reason it had gone bankrupt was because they were convicted of double selling grave sites. So the idea that there would be one grave on top of another was not so crazy. Because of this, she got invited to this weird thing called the FBI Citizens Academy, where they introduce people in the community to the FBI and problems, and through them got connected to a collection of nuns whose philanthropic goal for 1 year was to fight sex trafficking. And they were working with a small nonprofit that was a collection of event planners, like people that book hotels for conferences. And they had the idea to want to do something, and they were also at the FBI Citizens Academy, but they didn't have any technical background. Like their idea of something to do was let's collect images of hotels, but their technical background for that was like let's make a Dropbox folder and hope that people put pictures of hotels in it. And so Abby said, I think we can do better than that. And we built a system that has a very simple idea. We scraped every image online of hotels, like from Expedia, to make a database of images. We computed features from that database of images. So we have a database of images from someplace like online. When investigators have a particular picture, they compute features in that picture, and then you try to find the matching image in the database. So that was the system that we decided to build. And it turned out it was really important to get as much data as possible. Of course, that's the baseline of every machine learning algorithm, but we found that the pictures that were important in investigations were often not the same as the pictures that were taken on Expedia, because these are like somebody's crappy iPhone with bad lighting instead of really nice pictures. And we'll talk about this more later. But we made an app, and this app is still alive today. If you go search for Traffickcam, and it allows people as they travel to take pictures of their own hotel room and upload it to our database. And we got super lucky right when we launched this, and it was featured on in the US, Fox News and CNN International. And we've had more than 250,000 app downloads, 1 million images from the volunteers of the app that we've tied in with about 12 million images that we've also gotten from various online sources. And even though this app has been out for almost 10 years, we're still getting something like 130 pictures per day. And if any of you are traveling anytime, anywhere in the world, we really hope that you search for this app and contribute pictures. And I'm going to try to convince you in the rest of the talk why those pictures are so important. So that story comes in a little bit more of the teaching part of this. So deep learning is the current, for the last 5 to 10 years, craze of computer vision because it just beats all the other algorithms, and it's a really fundamental way of trying to understand imagery. And these slides are a little bit old, but the current models of deep learning are not all that different. And so what I'm saying is still super relevant. But deep learning starts with an image and it does a collection of layers of processing to get some sort of a vector that describes the image. And then that vector can be converted into a label. And so the most common uses of this are to have a class or a data set where there's a number of classes. This is some pictures from the formerly famous places data set. So the question is, can you take a picture? And for this data set, the kind of question you ask is it a bedroom? Is it a kitchenette? Is it a fire station? Is it a highway or is it a sandbox? And the way you might answer that question is to start with the image and then train this network so the right feature at the very end is on. So the top feature might be something like how much is this a phone booth? And the next feature might be how much is this a highway? And you train it so that the right feature is lit up for each image in your training data set. And that works really well. It works like from the perspective of somebody who's been doing computer vision for 27 years now. Like nobody thought this would work as well as it does. And one of the things that I think is most important is to try to visualize why it works so well. And so here are the kinds of features that it applies to the image at the very first of the many layers of processing. So one feature is how much does a particular part of an image look like a green spot? How much does a particular part of an image look like horizontal lines? It's learned all of these. And one interesting thing is that these features that it learns are not so different from the features that are at the very beginning of the visual cortex processing in the human visual system. And they're relatively different from the features people were trying to develop when we were building features by hand. And there's this amazing tool that's called DrawNet. I think if you search for DrawNet, or certainly if you search for Taralba and DrawNet, I know the whole URL is hard to maybe remember, but if you search for Taralba and DrawNet, you get to this page and it lets you look at things like for all the data in the places data set. If I click on one of these features, which image most strongly matches that? So if I click on this feature, this is the closet feature, and the images that sort of most strongly activate that closet feature are these. But part of what's interesting is how many of the low-level features are important for that. And maybe that makes sense. Like if you want to see a closet, it makes sense that you're going to have some vertical stripes because like the shirts that hang down give you vertical stripes. And you might have a strong horizontal edge because probably the top or the bottom of the closet has a horizontal edge. And maybe you have some colors, but you probably don't have that much of a checkerboardy thing unless you're like me and you have terrible fashion sense and you wear a lot of checkered clothes. You can also look so different final stages require very different low-level features, but collectively this network is trained to give good features for lots of different approaches. So that network is amazing, but we don't really need a neural network to figure out that our images of our hotel rooms. We have a database of 12 million images of hotel rooms, and all our queries are hotel rooms. So we don't need the hotel room classifier. We need to know which of the 200,000 hotels that we're indexing the room was in. And that's a different question, and that's challenging because it's unwieldy to have a final representation that has 200,000 elements in it. And if we did build a final representation with 200,000 elements in it, then if you added a new hotel to the database, you would need to rebuild your whole index. And so that doesn't work. So the way you do this, if you have a huge number of categories, is instead of having the neural network start with an image and go to a target label, instead you say, I want to take my image and I want to make a representation of that image. And you can think of this as a point in some kind of space. Really, it's a point in like a 1,000-dimensional space, and we're going to use, but you can think of it as a map, and it works kind of like that. And then the criteria you use to train the network, instead of saying, I want this image to go to a particular part in this map space, instead you say, I have an anchor image and then another image from the same hotel that we call a positive image, an image from a different hotel, and I try to optimize the network so that it doesn't really care where in the map you put each of these points, but you want to map the images from the same hotel close by and the images from a different hotel far away. And if you train this on 12 million images and 12 million squared or 12 million to the third triplets of images, then you can build a really nice map where, as much as possible, images from the same hotel get mapped nearby. And so you do this for lots and lots and lots of images, and they hopefully have features that are recognizably the same. So here, for example, there's a similar carpet, even though it's viewed from a different viewpoint. The bed and the bed linens are similar, even though they're viewed from a different viewpoint. And sometimes other data images are kind of similar, right? Like it's also a hotel room with a white bed and a carpet, but like the so sometimes the images from other hotels in some ways are more similar in terms of viewpoint, and you need the network to learn that it's like the things like the carpets and other features in the room that are the most useful. Once you build that representation, you have a large image database, and every image in your database is mapped to some point in your feature space. When you get a query image, you map that into your feature space, and then you look up what are the nearest neighbors of your gallery, and that's what you return as your search results. Um, so when you do this with old school networks that were not trained to match hotels, then like if you start with the original image and use the original places network, then you often find things that are kind of in some ways the same, like the relative position of the walls and the orientation of the carpets and so on are the same. But if you look at things trained for the hotel recognition problem, you find the same hotel often from a different viewpoint. Here's another example where the best results from the old network is sort of a bed in the same configuration, but the correct answer is the closest image we have in the database for the query is clearly the same image, but it's from a different viewpoint. And one of the nice things about this problem is when you, as a person, look at these images, you can often convince yourself, like, yes, this is the right answer, even though I've never been to the hotel, because, like, this is kind of a weird hotel room to have, like, a red pillow, like a red long pillow and blue pillows and a blue headboard. Like, that's pretty unusual. So we can look at this and be like, yes, I'm pretty confident that's right, even if we don't have any ground truth on the query image. Um, One of the really nice things that we have in our problem domain is that the National Center for Missing and Exploited Children has investigators for whom this is their full-time job, and they're willing to spend a lot of time with one image because sometimes that's the only clue they have for a particular data set. So if you were working for Google and you're trying to say, I want to make the best possible Google results, people say, like, you have to be on the front page of results. Like, if you're not in the top 10 results, and even more these days, if you're not in the top 5 results, people just don't scroll to the next page to find something. And for our case, we actually have um, investigators that will scroll through like hundreds and hundreds and hundreds of results because sometimes they have no other clues. And so if you allow yourself like 100 guesses, then we are getting up to, on a smallish data set, something like 50% accuracy. But we can do even better than that. So the reason we can do better than that is to understand something about our data set and the biases in that data set. So we have a very comprehensive database scraped from Expedia and Google Hotels of images from every hotel that Google indexes. And those are nice images, like they're explicitly nice images. Like the hotel manager went with a nice camera and took a picture and understood how to take a picture so that the inside of the room looks pretty and you can see both the inside and the outside of the room at the same time, which is pretty uncommon. And the rooms are all clean. And almost always they stand in the very corner of the room because they're trying to make it look as big as possible. And so that is the kind of images for which we have an image for every hotel in the world. And the images that our users take, the app downloads, are just, like wary tourists and travelers, like they get into their hotel room and they take a picture, and it's much worse lighting conditions, right? Like super bright windows and dark rooms, weird viewpoints where you don't see that much, really close up viewpoints where maybe you only see a headboard. And that kind of data is super important because this is much more what our query images look like. So one of our training strategies was to make sure that we always try to force the network to learn a representation that matches these kinds of bad query style images taken by our app users to an image of the same hotel from the Expedia data set. So we want to make sure that this representation is closer to this representation, but we're always giving it like a tough image to start with. So it has to learn to cross this domain gap between pretty images and more realistic images. And then we also do things like modify our images by adding things like in the use case, there's often times where there's like some kind of text or a telephone number in the images that are used in queries. People sometimes add Instagram filters. They also are a proxy for like weird lighting situations. And so if we add in the Instagram filters and the words in the image and this triplet design so that we have images from the Expedia and from our app, then we get much better accuracy overall and much better accuracy in our first results as well. So one question is, did it work? And this is I'll show at the end like this query now works in our database. It's like the 11th answer is the correct hotel. There's a great story about how this was originally solved, but one of the questions you might have when you're using the system is why did the network think two images were similar? And this is a great question as a developer of AI to ask yourself. Like, build the visualization tool that says, not just, did I get the right answer, but find a way to look inside the network and say, why does the network think things are similar? And it's really useful because it's really easy to build and train a neural network that just really likes bright spots or something. And like, there's lots of things that have bright spots. That's not a good feature for your network to be looking at. So make sure you look at what it's looking at. So here is a little bit of the answer of how does the network compute how similar the two images are? Well, it takes one image and it computes a feature, and it takes another image and it computes a feature, and then it computes the dot product of those two features, which is a measure of how similar those two features are. And this last step says actually what's happening is the network computes a feature at each location in each image, and then it just averages those features together in some way. And so if we want to, we can say instead of letting it averages features together, let's break it back apart and say for each feature location in one image, how similar is it to the whole image, the other image? And that lets you make a heat map of which part of each image is close to which part of each other image. So these heat maps explain what parts of the image are the most important. And so if you look at this, what you see is in this image, the ceiling is, so this is a heat map, like more red is more important, more blue is less important. So this is saying the bedspread and a little bit the headboard are the most important part from this image. And here the bedspread is really important and the headboard isn't that important. That's good that they both don't think the headboards are that important because they're different headboards. But this is a super unique and recognizable bedspread. So it's nice that it finds that the bedspread is important. A little bit of the curtains are important, and the ceiling isn't really that important. And so that is a visualization that suggests that the network is at least learning to key in on the regions of the image that you and I might think are important for that matching. Um, and so we now can use this as a tool in our search with a Center for Missing and Exploited Children. And they tell us they really like that feature because as much as we think our system is great, sometimes it keys on really silly things. And then they know that that's not a good match that they should think about further. Um, so I think this is the best matching image in our database. It's a different viewpoint. It's actually even a different color of bedspread on the bed. but it's still super clearly a match. This turns out to be in Mauritius, and the way this was originally solved um, was this fascinating Reddit thread where somebody, like it was posted on Europol, somebody posted it on Reddit, and then over the course of like a 72-hour weekend, there was some incredibly large number of comments with people saying totally sensible and totally not sensible things. But one person actually said, like, I stayed at this hotel. Here is a picture that I took from my vacation, and here is that exact picture. And then you can see that match. And so I think it's interesting to me that we work really hard to find this on as an AI tool, but also sometimes like sending it out to the world and hoping that good-willed people contribute is really valuable also. Um, so that's where I want to end this little lecture. I think I talked more quickly than sometimes, but I get super excited and I am happy to stay for as long as you have questions. And I've done a couple of these talks before, and the questions are fantastic. If you are still having questions at the end of this, you're welcome to send me an email. And I wanted to highlight that GW has just launched a very large initiative and program with focus on trustworthy AI across the entire university. So it sort of started as an effort in the engineering school, but now includes our international affairs school and the public policy school and this arts and sciences school. And I just took a screenshot as the talk started of this poll. And I'm not sure if what I shared today makes you change your opinion about this, but I thought this was a fascinating poll. And I think when people talk about trustworthy AI, people really key in on this like ethical use and privacy concerns, and you absolutely should. And I think sometimes my colleagues that think about that forget a little bit that AI also can be used to like I have a friend who has a child who's very dyslexic and cannot read, and so they just always take a picture and put it up to GPT and say, read this to me, right? And like that's an amazing like immediate use that some 12-year-old can do for themselves and really help. And we work really hard to find other super important use cases of that here at GW. So with that, I will stop and turn it back over to our colleagues on the panel, and I will be around until everybody leaves.
Thank you so much, Dr. Pless. That was incredibly insightful. It's inspiring to see how AI and computer vision aren't just theoretical tools, but technologies that can genuinely support investigations and help protect vulnerable communities. I think we all get a deeper understanding today of how engineering can directly serve humanity. Now, for many of you watching, you might be wondering, how can I build the skills to work on projects like this? And that's exactly what we are going to explore next. But before we hand it over to Catherine, let's do a quick pulse check with our audience with the next poll question that I'm just going to put share on your screen. What do you need the most help with in your study abroad journey? Please take a few seconds to answer this question. Is it deciding where and what to apply for, understanding how your profile fits different programs, presenting your story effectively in applications, or figuring out costs, funding, and affordability? We have over 200 participants currently, and I would request all of you to please take a few seconds to select the right answer that fits your journey. All right, I'm sharing the results now. Oh, there's a tie. There's a tie between understanding how your profile fits different programs and presenting your story effectively in applications. Thanks for sharing. This really helps us tailor guidance to what you need most. And now over to you, Catherine.
Okay, thank you so much. And thank you, Dr. Pless. That was such a fascinating presentation to listen to. I know I've heard it before, but it's always great to get to hear updates and to hear where you're at with it at present day. I don't have a lot to share, but we'll go really quickly before we get to those questions. I've seen that people are already submitting some, so we'll get to that Q&A at the end. Again, my name is Catherine Hugans. I am the Associate Director of Admissions and International Partnerships here at the School of Engineering and Applied Science. And I wanted to talk to you about what you need to consider when you're looking for graduate programs and what's really going to be the best fit for you. Especially if you're considering studying in the United States, we have over 4,000 universities across the entire country. And so it can be a little overwhelming to try and narrow down what's going to be a good fit for you. And so I always recommend that students, first of all, identify the actual program of interest. What you want to study, especially at the graduate level, is going to really dictate where you're going to want to focus your attention for applying for graduate study. So looking for the best programs, looking at the faculty. If you are familiar with research that you find exciting, where are those researchers working? Where did they earn their degrees? That can really help you to identify schools and programs that you might not have already been aware of. And then, of course, considering the location. Do you want to be in a larger city, a smaller city? Do you want to be in a rural setting? Um, do you want it to be cold? Do you want to have all four seasons? Do you want to never have to experience snow again? Those are all things that can help you to dictate what you might want to consider when you're looking at the US. And then, of course, facilities. What does the school actually offer? Where will you spend the majority of your time? If you want to do a specific type of research, are there resources available on that campus to help you to pursue that research? And then, of course, considering your post-graduation expectations, looking at the universities and the programs that will be able to assist you in getting the careers and launching the future that you're interested in. Are there career services? Is there a wide alumni network? And then, of course, the financial assistance. What does the university or the school actually offer in terms of scholarships and tuition discounts and assistantships and things like that? But the most important thing, of course, is just to keep in mind that we are always encouraging you to find the program that is the best fit for you, not the program that your best friend thought was the best fit for them or the program that your parents think is the best fit for you, but where are you really going to succeed? And so I'm going to talk a little bit briefly about George Washington, and that might be the right fit for you. So we are located in Washington, D.C., which is the capital of the United States. Our main campus is in the neighborhood of Foggy Bottom, which is right in the heart of the city. We're about 5 blocks away from the White House, 2 blocks away from the World Bank, the IMF, the State Department, other large international organizations. We have two other campuses, a residential one in the neighborhood of Georgetown and Mount Vernon, and then we have a research center out in Virginia near our main international airport in Dulles. We have shuttles that go between all three campuses that students can really take advantage of. And then we are unique in that we are predominantly a graduate institution. So we have around 10,000 students studying at the bachelor's level, and then we have around 15,000 students studying at the master's and PhD level. The university was given the great honor of being invited to join the American Association of Universities within the last few years, which we're really proud about. That really highlights the high level of research happening on our campus. There are only about 70 universities across North America that are a part of the AAU. So us getting to join that and to highlight the work that's happening at our Tier 1 research institution is a wonderful opportunity for us. Again, there are over 4,000 universities in the US, and we're on a very elite list that we're proud to be a part of. Now, the George Washington University is made up of 14 colleges and schools. So we have our Columbian College of Arts and Sciences, we have our School of Business, we have our School of Medicine and Health Sciences, but specifically, Dr. Pless and I work in the School of Engineering and Applied Science. We are made up of 6 academic departments that includes biomedical engineering, computer science, electrical and computer engineering, civil and environmental engineering, engineering management and systems engineering, and mechanical and aerospace engineering. And across those 6 academic departments, we offer a number of different master's and PhD programs. In fact, This slide says that we have 11 fields of study, but actually we have just launched a new master's program that is very relevant for today's topic. It is a master's in AI and machine learning, which we can definitely answer some questions about as we move forward. But I wanted to highlight that things are always evolving and growing here at the School of Engineering. We have over 80 tenured and tenure track faculty members who our students do get the opportunity of working directly with. And a lot of research is happening throughout our different departments, as I've mentioned already. Now, again, because we're located in Washington, D.C., our students really get the benefit of taking advantage of being in the heart of the Capitol. Our institution relatively medium sized, but the School of Engineering benefits greatly from the fact that we have about 1,100 students studying throughout all of our programs. So our programs are relatively smaller. Students really get the benefit of a one-on-one relationship with their faculty. Of course, the higher up your classes go, the smaller they become, and you really benefit from getting that expertise and that building that relationship with these experts in their field who are doing research throughout the region, who are working with different agencies, who have long-standing connections with different organizations throughout the DC and Maryland and Virginia region, including the World Bank, the Smithsonian Institution. Amazon has just opened a second headquarters nearby, Raytheon, and so many more. So really getting to take advantage of our location and our size can benefit our students greatly. Dr. Pless already mentioned, but our main building is the Science and Engineering Hall. It is actually where Dr. Pless and I are both speaking to you from today. This is the main hub for all of our graduate engineering students. It's where we have the majority of our classes. It's where we have our administrative offices, our career services. Um, there are a bunch of different study spaces as well that students can take advantage of, as well as some research spaces. So we have a Class 100 nanofabrication clean room. We have a high bay with a strong wall and a strong floor. We have some high resolution imaging suites, and we also have some collaborative research spaces and some interdisciplinary research spaces. So other hard sciences on campus have spaces in this building, like our School of Medicine and Health Sciences has a cancer research institute on one of the higher floors. They do some work in here as well. So students really get that opportunity to engage in engineering and other topics that they might be interested in. So we definitely encourage you, if you haven't already, to take a virtual tour of our campus. That link is definitely on our website and you can find it later. Um, Again, we do offer about 12 fields of study. You can see a list here of those that we offer at the master's and PhD level. Unless it says master's only, that means we offer it at both. We do have our master's programs are typically thesis optional, meaning you get the benefit of deciding whether or not you want to pursue research or if you want to continue with coursework only. Those programs are typically 2 years in length and they're 30 to 33 credits. Our PhD programs are typically 4 to 6 years in length. That will vary depending on whether or not you're coming in with a prior master's. We do allow students to apply direct entry, but that's going to be very competitive. We're going to be looking for some dedicated research experience, some publications to your name, some evidence that you're really prepared to pursue a PhD directly after undergrad. Um, the other thing to note about our PhD programs is that if you are admitted to them, you will be working closely with your faculty to identify the courses that fit both your interests and maybe fill any knowledge gaps that you may or may not have. So you'll personally design that coursework with your faculty advisor if you enroll in a PhD here at GW Engineering. Now, our application requirements, pretty standard. You need to fill an online application. If you've studied abroad, you will need to submit English language test scores. The GRE is not required to complete our application, though you are certainly welcome to submit those scores if you're proud of them. We do require letters of recommendation, 2 for a master's, 3 for a PhD, and then you need to submit a statement of purpose, resume CV, as well as your unofficial transcripts. And we do require that all students have the equivalent of a 4-year bachelor's degree. So you can email us if you want to talk about that a little bit more. In terms of scholarships, there is no separate application for funding if you apply for admission. you will be considered for funding. At the master's level, we offer merit-based scholarships that will cover a certain percentage of your tuition. Merit-based meaning that it's based on your academic performance in your undergraduate studies and the strength of your overall application in the applicant pool. And then at the doctoral level is where you'll see that more traditional full funding to offer. Our doctoral students are typically fully funded by the department through a teaching or research or graduate assistantship, which will typically come with full tuition coverage as well as a monthly stipend for living expenses. Now, I did want to highlight that we have our own W. Scott Amy Career Services Center here in the School of Engineering. Their office is dedicated just to assisting our engineering students in finding career opportunities post-graduation. They will often bring companies to campus, host interview days, they'll do career fairs and other learning opportunities. And they also offer services like headshots. They'll meet with you to review your resume, do mock job interviews. And if you do receive a job offer, they will actually work with you to negotiate that salary, that offering that you might receive, as well as assisting you with CBT and OPT support when you're going through those processes. I did want to highlight that we do have a number of graduate ambassadors, students throughout our programs that you can connect with and ask questions about their experiences. Um, we have a couple different students studying in CS and cybersecurity. So Knock is one of our CS master's students. So I would encourage you, if you're curious, reach out to them, chat with them directly. They would be happy to answer any questions that you might have about why they chose GW, how they're liking the program, what they think about Washington, D.C., or anything else you might be curious about. Now, that's the end of my prepared presentation. I did want to highlight that for attending today's session, you do qualify for an application fee waiver. That fee waiver is going to be SEED MC 2026. It is case sensitive, so just keep that in mind and feel free to take a screenshot, make a note, take a picture, whatever you find helpful. But the most important thing to keep in mind is that for Fall 2026, we are still accepting master's applications at this point in time, so you are welcome to apply for any of our programs, including our new MS in AI and machine learning, if you want to do a little bit more work in AI, as we've been talking about today. If you're interested in a PhD application, we are no longer accepting PhD applications at this point for fall 2026, but you are welcome to apply for a future semester. Our spring deadline will be September 1st, and our fall 2027 deadline will be next year, January 15th, 2027. Okay, but that is the end of my prepared presentation, so I'm happy, Chetna, if we want to open things up to questions now.
Yes, thank you so much, Catherine. That was extremely helpful. Now we'd love to open the floor for questions for both Dr. Pless and Catherine. But before that, let me kick things off with a few to get the conversation started. First question I'll ask Dr. Pless. Wait, I will put you on. Yes. Um, Dr. Pless, Traffickcam clearly supports investigators rather than replacing them. How do you design AI systems that augment human judgment instead of creating over-reliance or automation bias?
Yeah, I think that's a good question. I just typed out an answer to a sort of related question. I think there's places where AI is less controversial that are some of the big use cases that people have used forever. And my analogy to this is something like Google search is solving a problem. Like there's 10 billion or something web pages, you want to find one. You need some approach to try to find it, and Google provides that. You type in some keywords and it gives you an answer. And Google has sort of tricked us into thinking that if we don't find the right answer, it's our fault, right? Like we all have different strategies to try to use different words and rephrase the search. And I don't know if Google finds the answer you want more than 80% of the time. But if you didn't have Google or something like it, you'd have no way to solve this problem. So I think there's a bunch of problems that AI is an unmitigated good inside that problem domain because there's just no other way to solve that kind of question. So I think in our case, we can often give the first investigative clue about a particular image, and there's just kind of no other way to do that. And I think the economics and job impact of this depends so much on the industry. So the National Center for Missing and Exploited Children is a nonprofit in the United States, and I think they have a workload that could support 5 times more investigators than they can afford to pay. So if we can make our investigators 5 times more efficient, they can actually try to handle all the cases that they have, and it's not that we're limited, like it's not going to like take away anybody's job. And so I think that makes it super easy for me to be comfortable working on this project. I think that's a much deeper question in other places, but I'll
Yeah.
stop there.
All right, thank you. Catherine, the next question is for you. From an admissions perspective, what's one mistake high potential applicants often make that unintentionally weakens their profile?
Yeah, that's a great question. And I would say probably one of the larger mistakes that I see are, fumbles, accidental errors, would be not giving appropriate weight and time to your statement of purpose. In the United States, we do something known as a holistic review, which means we are truly looking at every aspect of your application. It's not just your final CGPA. We're also looking at the trajectory of your actual coursework. We're looking at those letters of recommendation. We're looking at your resume. And yes, we are closely reading that statement of purpose. So making sure that you're taking time to work on that statement, writing it yourself. AI is a tool that you can certainly take advantage of to help you maybe with brainstorming or cleaning things up a little. But you should not in any way be giving up your opportunity to speak directly to our faculty and our admissions office by letting AI write it entirely. This is your opportunity to really advocate for yourself. It's the one part of your application where you have complete control over the message that you're crafting, the narrative that you're sharing. You can't go back in time and change those grades you got in your first year of your program. You can't change your major now. You can't change what work experience you have. You can't alter what your recommenders say about you. But your statement of purpose is where you have that opportunity to speak directly to the admissions team and the faculty reviewing your application. So making sure that you're editing, making sure that you're paying close attention to what you're writing, really speaking to why you want to study at this institution in this program. Are there faculty that you want to work with? Are there courses that we're offering? Is there research happening that's really getting you excited? What I really want when I'm reading a statement of purpose is to come away understanding how GW engineering fits into your goals. I don't want to read a statement and then be like, that's really nice, but I have no idea why they're interested in our program. Um, and then, of course, please, 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 I know you're applying to many schools. Please put the correct university name. You do not know how many times I've read a statement of purpose for Georgetown University or Georgia Tech University or George Mason University. That's not our school, guys. And it highlights, unfortunately, maybe a lack of attention to detail that can be a little concerning when we're looking at applicants to admit. So pay attention to your statement, edit, revise, have other people read it, and make sure that you're giving it the appropriate weight.
All right, that was very much detailed. Dr. Pless, the next question is for you. Traffickcam operates in high stakes environments where decisions affect real investigations. How do you validate and stress test a system like this before deployment, given that you can't fully simulate the messy real world variability of investigative data?
Yeah, that's a great question. So I have a terrible answer for that. The terrible answer is we don't test this at all. We just deploy it. Again, it's in that space of if we think something is working better, um, we want to get it into the hands of the investigators as soon as possible so that they can have better results. But I think we also have we only deploy this. The only people that have credentials to use this are investigators at this one office in Virginia, and like they talk to us pretty often, so we like regularly check in with them, and if they say something doesn't seem to be working, like we respond to them very quickly. So in some ways it's like a tight enough collaboration. It's not like a usual customer, it's a more of a collaboration, and they help do the stress testing for us. um, One of the things we are working on next is they sometimes say like we have an image and there's a query image and there's some feature that I know is really important, but your model isn't keying on it very well. And one example recently was there was a hotel room with like a green door. And like green doors are just super unusual. I think they're so unusual that we never actually like the model never learned to use green door as a feature. And so we were looking at some of the vision language models, like the things that underlie the Dolly image creation technology, where you can type in words and it makes the image. We can do that the reverse way and say, I want you to make a feature of this image, and I really want you to focus on like green doors and find all the green doors in the data set and emphasize those. Um, so those are like the kinds of interactions we have with these custom with our collaborators, and that's my answer to that question.
All right, thank you. Catherine, the next question is for you. For international students, especially, what strategies have you seen successful students use to maximize networking and professional exposure while studying in Washington, D.C.?
Yeah, that's a great question. And what I would say is probably one of my biggest recommendations is to engage with our career services team as early as possible in your program, especially if you're here for a master's program. 2 years is going to go by so much quicker than you think it will. And so even though international students can't engage in off-campus work until they've been in the program for 1 full year, starting to engage with the career services team from day one can really help you to build that network with our careers team for one, and also get a sense of the different resources that they offer and connect with the employers and the alumni that they're bringing to campus to really help you to take advantage of those opportunities and start building your network early on. Probably the things that I see students maybe stumble on is not taking advantage of that office and then showing up, a month before they graduate and they're like, okay, I'm ready. What do I do now? There's not a lot you can do in a little amount of time that's gonna match in any way the importance and the value of doing that work early and continually adding on to it, updating that resume continually, learning about the different options that are happening, learning about companies that you might not be aware of that are looking to hire our students. Um, so that would definitely be my recommendation. Engaging with that office early, taking advantage of your faculty as well. All of our faculty have open office hours. So if you're doing well in a class, you're really engaging with their lectures, going to see them in their office hours and talking to them about your interests and seeing what options they might know about, or even maybe they know about a lecture happening or an event that you might be interested in attending that you would never have known about if you hadn't had that personal connection can always help as well.
All right. I don't know if the next question, Catherine, you want to answer or Dr. Pless wants to take, but it's a very generic question that I saw in the chat. What about the students who want to pivot from one career to the other? Like commerce student wants to get into AI now. So what advice would you give them?
Yeah, I guess I can try to take that. Except I don't know what advice to give. Like it really depends on each person, right? So like the master's degree in computer science or the master's degree in AI is a technical degree, and some parts of it are hard, right? There's a lot of mathematical sophistication and programming practice, and if you jump in too quickly, you can find yourself in a class where other people can sort of just like write a little Python program to do this, and then it's really hard if that's not part of your skill set. I think in the master's in computer science program that we have an onboarding track where people who have maybe programmed a little bit but don't have like an undergraduate CS degree or a lot of training, like there's sort of an accelerated what you really need to know about programming in 2 semesters to get ready for the rest of the master's degree. But I think if you're trying to change fields really dramatically, like from something like commerce, which may not have had that much of a technical background, like expect it to take a lot of work, and dive into it.
Yeah, somebody has also asked that someone who already has an MBA but wants to specialize in AI, what could be the second master's degree that you would suggest they would do at GW?
So I think for that, the well, there's a couple answers. Like I'm in the engineering school. I think our programs are awesome. GW is in general a good school, so our business school also offers, I think, masters in business analytics or like it has more and more of an AI flavor, and that might be the appropriate thing. I think there's value in pushing yourself to get the deeper technical background because I think you have better insights in the world if you do that. I think um, inside the Masters of Computer Science, like a Master of Computer Science and Master of AI, are degrees that we split out because even though you can learn a lot about AI in our computer science master's program, there's also sort of core computer architecture and core computer science algorithms research that we have as part of the master's degree. And I think the AI degree has more focus on the AI and statistics and mathematical background than the AI applications. So I think for that student, it might be that the master's in AI is the more directly applicable thing because learning enough about computer architecture might not directly approach those goals. Although I still think the master's in CS is my favorite degree.
All right, Catherine, as we wrap up, I will take one last question with you. What is that one tip that you would like to give students who are really applying for this year's fall 2026? One last tip.
Well, my most important tip if you're interested in fall 2026 would be to get your application in as soon as possible. For a master's application, our priority deadline was January 15th. So while we are still accepting applications, the farther away you get from January 15th, the fewer number of seats we have available, the less amount of funding we might have available. So getting things in as soon as possible will always benefit you. And then I would always say, just don't be afraid to ask questions. My office offers individual one-on-one virtual meetings. We offer my graduate ambassadors who you can connect with directly to ask about their student experiences. And then you can always email us at engineering@gw.edu, and we're happy to help you. We want to see your applications. We want to see you on campus. So please take advantage of us. We're here to help.
All right. A big thank you once again to Dr. Pless and Catherine for sharing their time and insights with us today. Today's session showed us something really important. One, technology isn't just about building faster systems, it's about building smarter, more ethical solutions that make a difference in the world. If you are excited about combining AI, engineering, and real world impact, the team at GW Engineering, along with us at C Global Education, would love to support you in taking the next step. Thank you all for joining us today. We hope to see many of you soon as part of the GW community. Have a wonderful day, everyone. Thank you, both of you.
Thank you so much. Have a good evening, everyone.